Hello everyone, I am Abhilash, working as Assistant Professor at Department of Mechanical Engineering, MIT, Mysore. So in today's session, I will be handling the subject of Engineering Graphics having a subject code of 18 EGDL 15 or 25. So far under the subject of Engineering Graphics, you have learned the concepts with respect to the points, then we went up with the lines, then we studied the planes. So from the few session, you are learning with respect to the concepts of solids. So in today's session, I will be continuing a problem with respect to the solids. Basically, you have already learnt the concepts of solids with respect to the square, pyramid as well as a pentagonal pyramid and the hexagonal pyramid. Now in today's session, let us take a square pyramid and rest it on a slant edge and see how the positions are going to vary. It's a different kind of a problem compared to the previous problem that we have solved so far. So let us look into the problem statement. What does the problem statement states? A square pyramid of 35 millimeter sides. So they are stating each side of the square is having 35 millimeter of base and 60 millimeter axis length. So you know what is a base and an axis in a solid. So here they are specifically mentioning the height or the axis of the solid is of 60 millimeter. Rests on HP. It is resting on HP on a condition that on one of its slant edges. So draw the projections of the pyramid when the axis appears to be inclined. This line becomes very important for us. The axis appears to be inclined to VP at an angle of 45 degree. So looking into the question, we have identified few parameters. Which are the parameters that we have identified? So this is the square solid pyramid that we have that we are referring. So each of the base is having 35 millimeter in its side, and the axis height that they have given, where all the slant edges are going to meet the point apex, which is the axis length, that is they have specified it to be of 60 millimeter, and they are specifically stating that it is resting on slant edges. So in the previous problem that we have solved, we have placed a square pyramid in this fashion and we have understood the concept and we have solved. But here, is it resting on a slant edge? No. Then what is the condition that we are supposed to do? Just rotate it, where in the top view it is going to appear for us that it is resting in the corner, which also satisfies the condition of a slant edge resting condition. So we know these are the slant edges, is it not? So these are the slant edges, and now it is resting on the slant edge on HP. There is a trick that you should remember. What is the trick? Whenever you see the problem as a slant edge condition, whether it is square, whether it is pentagon, whether it is hexagon, you need not to worry. Place the solid in the corner condition, in the first position. So this is the trick that you should remember. Whenever we see the term slant edge, it clearly states that it is resting on the corner condition. So now, what is the pyramid that we are supposed to construct? It's a square pyramid. So let us begin with our first position. What is the first thing that we are supposed to do? The first and the foremost thing is to draw the XY line. So we have drawn the XY line. Just let us name the lines X and Y. The other important thing is we should highlight VP and HP. That is the vertical plane and the horizontal plane. I am naming the vertical plane and the horizontal plane. Let us begin with our construction. It is a square pyramid having a base of 35 millimeter sides. So I have just marked a point. So from that particular point, it is to rest in a corner condition. Take your protractor, measure an angle of 45 degree in order to obtain the perfect corner condition. So take that particular condition. So for 45 degree line, draw a 35 millimeter side of base. 35 millimeter side of base. Again, similarly on the other side, you can begin your construction. Draw a 35 millimeter side for an angle of 45 degree. So we obtain two of the base sides with respect to the square. In order to obtain the other two, what you can do is just draw a parallel line with respect to the condition that you have already drawn to the one of the sides. So I am just drawing a parallel line with respect to the side that I have written for 45 millimeter, 35 millimeter, and again the final will be just joining this particular side. Now this is the first thing that we are supposed to do. We are supposed to rest a square pyramid in the corner condition. Now I need to identify the points that are clearly visible. So when I place this in the corner condition and when I look from the top, I can clearly see all the sides, is it not? So what I am supposed to do? I am supposed to thick this edges. Complete base is visible. So we are supposed to make that thick lines. So what you can do is just after drawing the condition, just make the line to be of completely visible. Draw the thick line basically. And name the corners. In order to name, be very careful. You can start from any of the corners. You can begin from here. You can call it as A, B, C and D, or you can call it from here itself A, B, C and D. Whichever the corner you wish to start, you can start with. I will begin from here itself. So I am going to call this particular corner as A. This is my B corner, C and D. Are we done with this? No. Whenever we look into the corner position from the top, I can clearly see the slant edges. Basically, the diagonals that are connecting the corners are clearly visible. So what I am supposed to do? Connect the corners from A to D and from C to A with the help of a thick line. So we are supposed to connect from B to D and from C to A, the diagonals with a thick line. So what is the final thing that we are supposed to do in this particular position? Show the dimension of any one of the side in order to complete this particular position. Take any one of the side, highlight that. These are all the fundamentals that you have already learnt. So draw an arrow, filled arrow basically, and call the sides of the given dimension. So here the given dimension is of 35 millimeter. So draw it as 35 millimeter. What is the next thing that we are supposed to do? We are supposed to draw the projection lines from the position that we have drawn. So draw the projection lines from each of the corner. Draw the projection lines from the each of the corners until XY. So the projection lines from the corner of C, from B to D, it's a common diagonal. So I can just draw a line from here to here, and from A again. So indicate your arrow. So we are just drawing the projection line. So in order to draw the front position, we should know the axis length. So we are resting the solid. They have clearly specified the axis length is of 60 millimeter. But if you observe in this particular position, one of the slant edge is overlapping the axis. So I need not to draw the axis chain link line. So what I can do? I can just draw a thick line of 60 millimeter, which indicates as the axis length, and connect from the other two corners. Can we clearly see these two slant edges? Yes, I can clearly see. So I can complete the first position of the given problem. So axis length, it is overlapped by one of the slant edges of 60 millimeter, surrounded by two other slant edges which are clearly visible. So in order to do that, let us directly go with the positions. So from here, this is my axis, which is overlapped by one of the slant edges, and it is clearly visible. So I am going to draw this with the help of a thick line for 60 millimeter. And the other two slant edges are also clearly visible. and the other two slant edges are also clearly visible. Connect from the apex point to the other corners. And the base will be thick. That sides will be clearly visible, so it is completely thick. Let us name the conditions. Here it is C, so obviously in the front view it will be C dash, it will be C dash. Here it is B and D. So B is clearly visible, D dash is not clearly visible, so I can call it as B dash of D dash. A, it is A dash. Which is the point all these are meeting? It is apex point, which is denoted by O dash. So call it as O dash. Again, we have forgotten to name at the diagonal. So what is that? It is O. It is O of O1. 2 points we have. O dash we have represented. What about O1 dash? O1 dash will be the base that is represented here. Now have we shown the axis length? No, we have not shown the axis length. So what we can do? Can just extend the line. Dimensioning is very important in the engineering graphics. So just draw the line, filled arrow, highlight the axis length, that how much they have specified. The axis length they have specified it to be of 60 millimeter. So draw, right, 60 millimeter. So we are done with the first position for the given condition. What was the condition? A square pyramid was of 35 millimeter sides and an axis of 60 millimeter length resting on HP. In order to begin with the next position, that is the second position, let us look into the condition that they have specified. They are specifying that rests on HP on one of its slant edges. In the HP, one of the slant edge has been completely resting. One of the slant edge has been completely resting. Now we are at this particular position. We have drawn the front and the top view of it. Now what they are stating, one of the slant edges is completely resting on HP. It is completely resting on HP. So we are supposed to transfer this entire front view into the HP, ensuring that one of the slant edges, either O dash of A dash or the O dash of C dash, resting on the HP. How to do that? There are two ways to do that. One is with respect to the arc method. Take your compass and pencil and then continue with that. You can just measure from the sides, or the other is just transfer this into completely on the XY line. To begin with, measure from O dash to A dash or the vice versa. O dash to A dash. Identify a point first. Identify a point. Call the point to be of A dash. Call the point to be of A dash. So I have identified the point of A dash. So from A dash to O dash, cut an arc. A dash to O dash, cut an arc. Just transferring the entire slant edge, because the given condition itself is such that one of the slant edges is completely resting on HP. So O dash of A dash. So this point will become my O dash. O dash. So what are the other things that we are supposed to transfer? O dash of C dash and A dash of C dash. So that I can do with the help of an arc method. Measure the distance from O dash to C dash. Measure the distance from O dash to C dash and cut an arc. Because we don't know where exactly the point is going to meet. Where is the other thing that I can measure? I can measure the distance from A dash to C dash. So measure from A dash to C dash and cut an arc. So here it is going to meet at this particular point. So keep the arc, which is the point that we have obtained now. We have obtained the point of C dash. Now I can complete the second position, the outer boundaries basically. this particular portion is a thick line, that is from O dash to A dash. O dash to A dash is a thick line. From again A dash to C dash is a thick. From O dash to C dash, so what is the left out thing now? The left out thing is the point of B dash, of D dash and the O1 dash. It is exactly at the center. You can just measure the distance from A dash to P dash, D dash and cut an arc and call the point of B dash of D dash. It is also a point of O1 dash. Now connect from the point B dash to D dash to the O1 dash such that it completes the position. It completes the position. Now we are done with the condition that they have specified. What they have stated that one of the slant edges has to be completely resting on the HP. We have transferred that. There might be a question that, sir, can I transfer O dash to C dash? Yes, you can transfer that, but this particular position will become reverse because we are resting from here to here. So this will become mirror image. So this is from here to here we have transferred. From here to here it will be reverse. In order to complete the second position, just draw the projection lines. Draw the projection lines to the corresponding points only. Don't extend the line further. From A dash we are supposed to draw the projection lines. So from here we can draw the projection line. So call the point then and there itself so that it will avoid the confusion. This particular point is my A. Then we have B dash of D dash. B dash of D dash. It will be a parallel line. So just draw the line. So from D we have draw the extension line, the projection lines basically, and again from B draw the projection line. Again from B draw the projection lines. Identify the points. Identify the points. So this is my D, this is my B. So the next projection line is from the point C dash to C, from C dash to C. From C dash to C. So it's just an extension of the line from A. We have done with that. So call the point to be of C dash. So this particular point is C. Now we are left out to identify the point of O dash. Basically O. Just draw the projection line. Just draw the projection line. Draw the projection line, and O is here at the center. So extend the line. These are all the projection line, the thin lines that we are supposed to draw. So call the point to be of O. So we are left out with only O1. O1 and O1 is going to meet here. So the point is here. So we have identified all the points correspondingly with the help of the projection lines. Here is the projection lines. And from here also we have projected the lines. So now I am supposed to complete the second position. How to do that? We know the certain rules in order to do that particular positions, is it not? What is the first rule? The outer edges or the faces are completely visible. Outer edges or the faces are completely visible. So based on that, let us complete that first condition itself. So outer edges or the faces, A to D completely visible, A to B completely visible, D to O visible, and O to B is visible. So just with the help of a thick line, complete that particular position. With the help of a thick line, complete that particular condition. A to B is the outer edge, O to D is the outer edge, D to A and A to B. These are all completely visible condition. These are all completely visible. Now if we look the solid at that particular position when it is resting and when the observer is here, you can clearly see the entire base, is it not? All the faces of the base are clearly visible for him. So based on that particular condition, I can finish the bases, or I can connect the bases with the help of a thick line. So from C to D it is completely visible, from C to D it is completely visible, and again from C to B it is completely visible. Now the second condition that we are supposed to follow is such that the edges or the faces nearer to the observer is completely visible. So with this the edges which are or the faces that are completely visible, O dash to C dash, it is very nearer to the observer and you can clearly see that edge. So O dash to C, it is completely visible. Again C dash to B dash, it is completely visible, and C dash to B dash, that we have already done. C to D, C to B. So only thing that is left out is O to C is completely visible. So make that thick line. So O to C is completely visible. Make that a thick line. Now what is the other thing that is left out with? We are left out with O dash to A dash, which is far from the observer, which you cannot see. So what is the method that we are supposed to make use of? We are supposed to make use of the dotted line. So in order to connect that, so O dash to C dash, this we are supposed to draw with the help of a dotted line. So this completes the second position, where the first rule that I applied is the outer boundary edges are or the faces are completely visible. The second condition is that the faces or the edges nearer to the observer is completely visible for him. So we have based on that conditions, we have completed the second position. In order to move for the next position, we should refer our question. We have completed the two conditions that they have specified. One is a square pyramid 35 millimeter, 60 millimeter axis of length rests on HP on one of its slant edges. We rested it and we have completed the position. What they are stating next? They are stating that draw the projections of the pyramid when the axis appears to be inclined at VP. It is not inclined exactly. They are stating that it is appears to be inclined at VP. This particular lines itself should provoke you that there is no beta angle in this particular problem. So we need not to calculate the beta angle as we used to do in the previous cases. Like if they are specifically mentioned, like when the axis is inclined to VP at 30 degree, 45 degree, we are supposed to calculate the beta angle. But here they are clearly mentioning it is appears to be inclined at VP at an angle of 45 degree. So we need not to calculate the angle of beta. Just identify a point anywhere on the XY line and transfer this entire second position for that particular 45 degree VP line that we are going to draw. Okay. Now let us begin with the final position where they are stated that the axis appears to be inclined at an angle of 45 degree. So I am drawing a line which is inclined at an angle of 45 degree. Indicate the angle, that is very, very important. Indicate the angle at an angle of 45 degree. What is the thing that we are supposed to do? We are supposed to transfer the entire second position for this particular 45-degree line that we have taken. How to do that? With the help of an arc method basically. So first we'll identify a point. Let us identify a point and call it as point O, such that the other things become easier for us to transfer. So we have called the point O. So we know O and A are on the same line. So O and A will measure the point and will cut an arc. So we have identified the point of A. This becomes very easy for us. Then we have C also on the same line. Either you can measure from A to C or you can measure from O to C. We'll measure from O to C itself. We'll measure from O to C itself. So measuring from O to C, measuring from O to C. And then the other thing that we are supposed to transfer the other point, call the point as C. Call the point as C. Naming at then and there itself will make the problem easier for us. So now what I am supposed to do? I am supposed to measure the distance of a slant edge from O to D. It will be same from O to B also. So you need not to measure twice. So measure from O to D once, measure from O to D, cut an arc. Similarly from O to the other point, that is B. How to complete it? Measure from the distance from A to D, the arc method, A to D, it will be same from A to B also. So measure from A to D, measure from A to D, transfer the points A to D. Are we done with all the points? Yes, we have transferred all the points A to B, C and D. So we are supposed to finish the second position. We have inclined the condition at an angle of 45 degree as they have mentioned in the problem. Just connect this O to D, O to B. We are just transferring, you need not to worry which is thick, which is thin line. Just transferring the second position. We have O1 also. We are supposed to identify that. For that you can do a simple method, measure from A or from the C. It will be exactly at the center, but still we are supposed to identify that point. So this is my O1 point. This is my O1 point, and it is a dotted line. So in order to finish my final position, what I am supposed to do is, I am supposed to draw the projection lines from this particular position. So how to draw the projection lines? They are the thin lines that we are supposed to draw. Projection lines are the thin lines that we are supposed to draw. Let us begin from each of the point and we will complete the position. But ensure that while drawing the projection lines, don't exceed the lines. Okay. So we will begin from the point D. We will begin from our point D. So here, so D approximately comes over here. Just draw the line. Identify then and there itself the point so that it becomes easier for us to complete the position. So this is my D dash. Similarly, I am supposed to draw from all the edges, that is from A. A is exactly at the XY line. A is exactly at the XY line. So draw only up to the projection line up to the XY. So name it as A dash. In the front view, we are going to call the name with a dash, A dash. Again from C, draw the line, projection line. The projection lines are the thin lines. Again from C dash, supposed to draw a projection line. Name the point then and there itself. So this is my C dash. We are left out with the B. So B is here. B is here. So call it as a B dash in the front view. Then we have O. O is on the XY line itself. O is on the XY line itself. Just transferring that. O is on the XY line itself. So this is my O dash. And then we are left out with O1, O1 dash and O1. Let's draw the projection lines. Draw the projection lines. So this is my O1 dash. This is my O1 dash. We have completely transferred with the help of our projection lines for the final position. So indicating the projection lines. You can just put an arrow in order to indicate the projection lines. Now we are supposed to complete the final position. How to do that? Again, apply the conditions that we know. What is the conditions that we know? The first condition is that the outer boundary or the faces are completely visible. So we will begin with the outer boundary. Which is the outer boundary here? C dash is an outer boundary, D dash is an outer boundary, A dash and O dash. So from O dash to C dash to D dash to A dash, and again D dash to O dash is an outer boundary which is a completely visible. So make it a thick. Now we are supposed to apply the second condition. What is that second condition? Now initially it was here, the first position. Then we rested with the help of a slant edge completely. Then we have inclined at an angle of 45 degree. Now the observer is here. He can clearly see all the base edges completely. So what I can do? I can apply that condition and make it completely visible. I can make it completely visible. So which is the connected? C dash to D dash is already done. A dash to D dash is done. So the left out is C dash to B dash and B dash to A dash. So connect from A dash to B dash and again from C dash to B dash. Now let us apply the other conditions. What are the other conditions? For the observer, the faces and the edges which is nearer are completely visible. So which is the nearer edge? O to B is one which is completely visible, and again O to B to A is we have already done. So the edges that is nearer to the observer is from O to B. Where is from O to B? So O to B it is completely visible. So make it a thick line from O to B. It is completely visible, and the edges or the faces which is far from the observer are not clearly visible. So which is that particular edge? It is O to D. O to D. Here it is O dash to D dash, which is not clearly visible. So just draw a dotted line. Now the other thing that is left out is the axis, that is O1, which is an axis line. Just represent that with the help of an chain link line, that is a line dot line dot line. So this is the final position for the given problem. So this completes the given condition where they have stated us to rest in on the slant edge on HP and inclined, it is appears to be inclined at an angle of 45 degree. So with this, we are going to conclude this particular problem. In the next session, let us begin with the other two conditions. Like let us take an example of a pentagonal pyramid and then we'll solve the problem, and the hexagonal pyramid, and we'll try to see how the conditions are going to appear. Thank you.